In this video, we're going to discuss user-centered design. User-centered design is a philosophy of designing an interface with the idea that what we want to do is design this technology around the needs of the user so that we best fulfill the user's needs, whatever they are. In this process, we recognize that there are different levels or different importance of user needs, even at the very highest level. So if we look at this graphic on the bottom, we can see that there are multiple possible goals that we may have in our design. One of those is self-evidency. So if we have a user interface, say for a web page, where we want all users from the World Wide Web to come and use our web page without any training or introduction, then self-evidency may be our primary design goal. That may be what we want to achieve. However, in a system where it's possible that a user is going to become harmed, perhaps maybe self-evidency isn't the most important design goal that we want to achieve, but instead perhaps safety is. Or maybe we have an interface where the speed of the user's reaction to an adversary becomes essential for their survival. And in this case, we may want to design the interface with speed as the primary indicator of success rather than self-evidency or even safety. So in this process, what we want to do is we want to determine what it is the user's needs are, and then we're going to design the system to achieve that. It may be that to actually achieve speed or safety, we may have to sacrifice self-evidency, which may mean that we need to institute training or other methods of overcoming those deficiencies which we've added in the area of self-evidency within our design. And so we need to keep in mind that there are trades among these different types of attributes of a system, and that we want to determine from our users, even at this very high level, what it is that we want to achieve. And so from user-centered design, what we're trying to do is understand what it is the user's needs are, why they need these certain things, and be sure that we deliver what they need so that we're able to help them achieve their overall design goals that they have in the end, or their overall use goals for the system. In user-centered design, we're going to do this primarily through an iterative process. And this iterative process allows us to begin to understand at a deeper and deeper level what the human's requirements are, and then to modify our system to achieve those requirements, or to deliver to those requirements. So many of the words I'm using sound like words that we've already used in our systems engineering classes. So is user-centered design really different from SE, or is it much the same thing? Here's the way I think about that. From some perspectives, this process is very similar to most SE processes that we use. It is a very top-down design approach, which is oftentimes the way that we teach you to think about systems engineering, at least from the first approach of the system. That is, we're going to start by understanding what we think the requirements are, and we're going to begin to design the system to that. This process, though, is much more like a spiral model than a waterfall model, in that this understanding of these requirements is thought to be an iterative process, because it's very difficult for a human to necessarily understand what their requirements are, convey what their requirements are, or for us to be able to project what their requirements are. Instead, we're going to arrive at these requirements through iteration and iterative understanding. On the other hand, user-centered design is somewhat different from SE in that it has a very different emphasis. And so I want to just talk about this different emphasis in the following way. So as an SE, what we might do is we might be asked to acquire a system. Right? We might be asked to acquire, for instance, a UAV control system. And so we're going to define the requirements for that UAV control system, and we're going to have it built by our contractor and delivered to the Air Force. Perhaps in a different acquisition process, we might need a comm system. And so we might have a different contractor build a comm system for us that again can be used to achieve some mission level goals. However, when we put these both in front of the human operator, we've not necessarily designed them for use by that single operator. And so we may have a UAV control system that requires a keyboard, a mouse, and a display. We may have a comm system that also requires a keyboard, a mouse, and a display, but a separate keyboard, mouse, and display. And so now the user is left to juggle these multiple input and output devices to achieve the overall mission. And at times, that makes them feel a little bit overwhelmed, perhaps, and so they feel like they have to perform as a superhero to actually make use of this system. In user-centered design, we're going to place our emphasis of our design upon not what we need to achieve the mission so much, although that's also important, but what we're going to do is try to design the system so that it really meets the end user's needs. And so we want to design this system that's integrated around the human and provides the human a level of comfort in their ability to use that system. Now that doesn't mean that the underlying system below that system isn't complex. In fact, we might have a UAV control system and we may have a comm system, but if we've designed each of those with open interfaces, we can now design an intervening system which takes output from each of these two systems, delivers it to a single display perhaps, that the user is able to interact with through a single keyboard and mouse, and that feedback can be provided then out to each of these individual underlying systems. And so if we do the design of this user interface system well, we should be able to make the user much more comfortable that they can achieve the goals without having to jump between multiple keyboards and mice or perform other relatively superhuman activities. Oftentimes, some of these superhuman activities come from retrofits, right? And so here's an example of a retrofit. Whoever built this building probably built it before there was a requirement to provide handicap parking, and so when that requirement came down, they came out and they painted a logo on an existing parking spot with a handicapped symbol. But note, unfortunately, that the parking space is probably not wide enough for a van with a wheelchair lift. There is no access path for the wheelchair onto the sidewalk. It's a retrofit, right? So this handicapped person now has to become that superhuman to jump their wheelchair over top of the curb to get into this building. And so we oftentimes see that by not designing a system around the human, we're trying to retrofit some existing systems so that the humans can actually be successful with them. And that level of success may not be the ultimate level of success that they could achieve had we designed the system around the human. So with that, what we're trying to do with user-centered design is to design the system around the human with a lot of user feedback so that we refine what we believe are the requirements and the overall structure of that system is as early as possible so that we eliminate as much risk as early as possible of the design and therefore provide a highly usable system at the bare minimum cost of doing so. And so what we're going to do is we're going to begin by looking at what the users need early in our system design rather than necessarily understanding what the technical considerations of our system is, which again maybe sounds a bit SE-like in the way that we're describing this. But we really do want to understand what the user's needs are so that we can decide what the right technology is to bring to bear to aid the users. Oftentimes, as we're doing this process, we're going to see that there is an existing system. There's some way that the users are performing some task, And what we're trying to do is design a system to make them more effective or efficient in performing that task or that set of tasks. And so oftentimes in our design process, what we're going to begin by doing is looking at the existing system that's out there, and we might conduct a task analysis of that system, as we might try to determine what are all the tasks that the human is trying to do with this system, or that they're required to do with this system. And as we do this, we don't only want to understand what it is, what are the tasks, what are the actual things the human has to do when they're using the system, but we want to understand their goals using the system. Why are they doing these things? What are they trying to achieve? And if we're able to do that, if we're able to understand what it is they're trying to achieve, then perhaps we can find a better way of helping them achieve those overall goals. Also, early in the system concept design, as we're looking at the existing system, we probably also want to conduct some empirical measures of our existing system. That is, we might want to actually take our existing system and run some sort of a usability test where we require the user to perform the set of tasks that they're doing in the environment that they have. And we look at the types of errors that they make, how long it takes them to perform each task as they do them. And we try to identify tasks where we could provide technology that actually enables them to perform those tasks much more effectively and efficiently. And if we can do that, we can begin to identify things that we want to allocate away from the human and towards some automated process. As we begin to do our design, we want to design the system iteratively and allow it to evolve, so that we really make sure that we're taking user input and we're trying to use that input to understand better what it is our system should do. There's many ways we can do this. Two that are listed here is one is through this idea of participatory design. And that's a design process where we bring users into the room and we sit down and we try to design the system together. I think you probably will see this happen quite often in many of the acquisition processes we have now, where we're bringing in perhaps a pilot or some other individual into a design process and asking them to help us do some part of that design, because they bring that end use knowledge into this design. Unfortunately, one of the problems with that is that each user oftentimes has a different way of approaching a problem, and so we might have this one user represent this whole user community, and we might design the system in a way that he or she thinks the system should behave, but we may find that they're an outlier and that most of the other people actually would think about performing this in a very different way. So we have to be careful with participatory design in that these individuals that are there working and using these systems, they understand what needs to be done. They don't always understand the best way to achieve, though, the final outcomes. And so they may limit their thinking somewhat, or they may, again, not represent all other users. Another process that we can use is through prototyping of the interface. That is, trying to develop, to begin with, very crude prototypes of what it is we want to build, and taking those back to the user and showing them and having them use those prototypes as well as we can. Now, in the project in this class, we're not going to be able to actually ask you to create a software prototype of a system, but what we will be doing towards the end of our project is we're going to try to do some very crude prototypes. We're going to try to do some storyboards or paper mock-ups of interfaces and use those to help get some feedback from users. These prototypes in the early stages don't have to be all that robust, right? We can create prototypes that are just drawings on paper and show them to people and gain feedback from those, and then we can use those to begin to iterate our prototypes. We might go from prototypes that are just sketches on paper to going to prototypes that are kind of like a set of PowerPoint slides which show some of the interface pieces and let the people sort of click through some of those interfaces and see and provide feedback on those, to then integrated software which allows some branching to happen but maybe doesn't actually perform anything in real time, and then maybe to prototypes where we begin to have some simulation behind those prototypes where there's more real-time interactivity, and finally to prototypes that are actually embodied in our real systems. Each of those prototypes, regardless of how crude they are or how fancy they are, can be very useful in gaining user feedback. And so what we want to do is we want to design a prototyping process where we fail fast and we fail often, right? We want to fail as often as we can with those early paper prototypes, because those can be generated really rapidly. So if we have to go through multiple iterations of those to get to what's right, then let's do that. Let's not spend a lot of money creating a really fancy prototype that we're going to show to a user and realize 10 minutes later that that was a really bad prototype, right? If we've done our job and we've done some paper prototyping, hopefully that first software implementation we have is actually not bad. And so we want to create these really rough prototypes early and fail fast and fail often. The overall user-centered design process is pictured here. And what you can see is that we're going to start with a vision of our system. We're going to define our ConOps. With that system concept in mind, we're also going to think about what our business objectives are. What do we really want this system to achieve for us? And in doing that, we're going to begin to understand things about the environment, things about the users, things about the environment, the overall business or military environment we're going to use this system in. And through that, that's going to help us shape some of the requirements we have for our interface. It's really in this stage where we're thinking about things, very high-level things, like what is the emphasis of our interface? Do we want speed, or do we want safety, or do we want intuitiveness as being that first top-level goal? And also understanding what some of the constraints are within these environments that we're dealing with. From that, we're going to begin to analyze requirements and user needs. And in doing this, we're going to begin to try to understand what the goals are that the user is trying to achieve, and we'll begin to flesh out some of the functionality that we need to support those goals. And begin to take those down to deeper and deeper levels, eventually beginning to allocate those functions between the person and software, person and system, some way as we do that. We'll then go into conceptual and detailed interaction design. And in conceptual design, we may start with something like a scenario where we provide a day-in-the-life description of the way a person's going to actually interact with our system. We might also provide things like descriptions of the metaphors that we're going to apply to sort of help them understand the way that our system operates. Or we might try to describe the mental model that we believe they have that we're going to try to leverage into our system design, which oftentimes is derived from the metaphor that we're trying to use. And then from that, we're going to begin to determining what the actual processes are that we're going to embody within our interfaces, and then how we're going to take those processes and actually instantiate them as graphics on a screen to create an interaction. And once we have those, we'll again, we want to do this iteration. We want to get some system feedback. We want to apply those learnings to update all of our analysis and update our designs. At the very front end, the things that we're trying to do is determine what are the overall goals the users have, and what functions do we need to support those goals. What are those high-level functions we need to support the goals? We're going to determine things like the environment and conditions, which provide limitations upon the way that we're going to actually implement these functions and achieve these goals. We want to understand the users, which again might provide another level of restrictions that we have. Can we afford to train the users or not, for instance? And then from this, we'll begin to set up preferences and priorities for our overall interface design. So this is some of the front end types of work that we'll do. During this process, we don't only want to understand what it is that people want to do, but we also want to understand why they want to do it, right? We want to really be able to empathize with the user so that we understand what motivates them, and so that we're able to design this interface in a way that supports not only what it is they're doing, but helps them feel good about the way that they're doing it. Helps reinforce why it is they're doing this final thing. As we go through this process, as I said, we'll start with defining those user functions. We'll start with some very high-level functions originally. We'll get some feedback from users. We'll begin to take those functions down to lower and lower level functions. And as we do this, we're going to talk about this as establishing what the goals of the users are, and then what are the functions we need to support those goals. And we'll gain feedback on the user from both the goals and the functions as we develop those. From that, we'll start to develop a mental model, the way that the user thinks about this overall system, and we'll get some feedback there. We'll start to design the overall process flow of our system. And the process flow is oftentimes very important in software because we want to make sure that we have effective and efficient methods of navigating through the information that we have, right? So we might want to make sure that we have a design process where we maybe start at screen A and we move down into screen B and into screen C, and we fill out the information and it's all there, versus having some convoluted flow where maybe we move from screen A down to screen B down to screen C. We realize we need some information that's actually in a different branch of our hierarchy, so we have to move from C back up to B, back up to A, down into D, down into E, down into F, find the information, come back from F, back to A, back down to B, back down to C, and then input the information, right? We don't want process flows like that. We want process flows that are clean and well designed, and so we need to work through those before we actually start putting things down on paper for the actual interface design. So we'll work through those processes, we'll get feedback from the user on those processes, and then we'll begin to actually create the interface, right? How do we actually then put this process down into a graphical depiction or some other depiction that the user can actually interact with? And again, we'll get feedback from them. So these are the types of steps we're going to conduct as we go through this user-centered design process, both that upfront analysis as well as these lower level processes with this iterative design. In this course, we're going to use a project to actually demonstrate many of these, and so we'll have you walking through this process in a very prescribed way to achieve the overall project we have in this course, which is a full quarter-long project. And so we'll be just providing you deliverables each week that walk you down through this user-centered design process, at least down to some initial interface design concept mappings. We're not going to require you to create software. We'll get down to where we have some paper prototypes of the interface, but we're never going to actually implement any of that in software. In a real system, we would want to once again to implement those designs of the interfaces into some crude prototype software, and then eventually iterate them down to higher and higher fidelity software, with feedback happening with each iteration. But again, we will fall short of that in this course. As we are thinking about the design of these systems, we want to really think about what's the goal the user is trying to achieve, and we're going to look at the things that they have to do to achieve that goal, and we're going to want to make sure that we support those things within our interface. We're also going to want to make sure that as the people actually implement the steps that they need to accomplish that goal, that we provide not only this path forward down to the world, that we also provide some feedback to them, right? And so in our interface designs, we want to make sure that we identify the goal and that we provide steps which allow them to move down through a plan, to specifying that plan, to performing that plan, and back up to where they're able to see the impact of the steps that they performed, interpret those to understand whether in fact they have achieved what they've specified, and then to compare the outcomes back to that plan. And so we want to make sure that we support the accomplishment of these goals through each of these steps within our interfaces. Throughout the course, we're going to introduce you to a number of different design principles. And so we'll be doing that through some videos and lectures throughout the course. You'll see some of those in your book as well. And although the two sets of information, the presentations that you'll receive in this class and the book may appear somewhat disconnected, each of them are trying to help you understand some of the fundamental design requirements or design tools that are available in this space. There are many ways of looking at this overall system design, and so we'll introduce you to a few different views of those. Schneiderman, in his book, gives you one view. We're going to review a couple of other books which give some very different views of interface design. We're kind of leaving it up to you to sort of integrate those and use all of that information in the projects that we have in this course. But understand that these are different viewpoints. Not one of them is necessarily correct or incorrect. They're just different approaches to the same problem. Or perhaps one might say separate approaches to subsets of the same problem. Here's 7 fundamental principles of design according to Norman, which if you have read his Psychology of Everyday Things, you've certainly been introduced to these. These are a list of design principles, and as I said, the other material you'll receive in this course are going to introduce you to other design principles. And as we do this, what we want to do is introduce you to these design principles so that you avoid as many bad designs as possible. We oftentimes become unaware of the bad designs in our world just because we fight through them so much every day. But how many of us have seen things like this, where we see a pull handle on a door with a label that says push, right? It's easy to discover which of these. We grab the handle, we pull on it, does the door open? If it does, then okay, pull may have worked. Maybe we go ahead and push on it as well, just to see if push would have worked as well. And we gain feedback on those, and so we know how to navigate this door. But we shouldn't have to do that, right? We should be able to look at this door and know right away whether we would pull this handle or whether we would grab this handle and push the door forward for some reason. Unfortunately, there are many bad designs in the world which preclude us from taking those steps. And many of these are for really simple things, right? Should I go up or down the elevator? Well, does this label go with this button, or does this label go with this button? It's difficult to say. It would be easy to put a metal mask around, say, these two down here, and we would know then that this goes with this button and this goes with this button. But we have to provide some sort of signifier, something that links those things together to indicate which is which. Most of these designs we're able to fight through in the world, right? We press a button, we see whether we're going up or down, which lights light up on the elevator, and if we're wrong, we press the other one. Okay, so that maybe delayed us a few minutes, but it didn't cause any catastrophic problems. But sometimes they do, right? So here's this pitcher is a very successful pitcher out on the market. If you've used one of these pitchers, one of the things you realize is you have to place your hand here and you have to place your thumb up on top of this lid. And as you pour water, if you've placed your thumb on here, your thumb holds this lid down and the water only comes out this little spout right here. Unfortunately, if you don't realize that you have to place your thumb there and you tilt this thing too far, this entire top will fall out onto the desk, and all of the water that's built up underneath of it is going to flow out as well and give you a nice shower. So to recover from this nice shower takes a few extra minutes and perhaps a lot of embarrassment. And so some of these bad designs do in fact become much more consequential than others. Now this wasn't life-threatening, but perhaps if we're driving a car or something like that, then a bad design might lead to something that is in fact life-threatening. And so we certainly want to avoid those types of things. And as we'll say within this course, one of the ways that we avoid these bad designs is that we understand what some of the design principles are that we're going to introduce, and we apply those design principles early in our design process. However, we also have to recognize that we'll never find all of the right design principles, and so once we've implemented these, into an interface, then hopefully we're willing to go test that interface and see whether we've missed a principle that we should have embodied within our design that now the users find and understand to work in a very different way than the way that we intended. And so it's important not only to apply design principles, but to apply some sort of iterative design process to gain user feedback.